Alrighty, so today's lesson is on probability. I'm sorry I can't be there today with you guys, but please make sure you are following along and you are using the handout and filling in everything that I'm filling in on mine, and making sure that you're actively listening and pausing when you need to, rewinding when you need to, if you need any extra time, or asking Mr. Mossberg if you have any questions. Alright, so we're going to talk about probability. You have probably talked about probability in other years, probably starting in maybe 3rd or 4th grade. So you probably have a good idea that probability talks about the chance of something happening. When we talk about something being impossible, it has a 0% chance of happening. So it is impossible that I would be a middle schooler because I've already been a middle schooler, so that's a 0% chance of happening. If we talk about something that's certain to happen or has 100% probability, that would be you guys being in middle school, okay? You guys are definitely middle schoolers and you're going to be middle schoolers for another year. That is a 100% chance. When we talk about an even chance, that's our 50-50 shot. So think about flipping a coin in the air. Alright, so number 1, probability describes how likely something is to happen. We can write probability in different forms. So thinking about that coin again. Alright, so you see we have the quarter at the bottom, and it has a head and it has a tail. So if I were to say what's the probability of landing on a heads, well, if we wanted to write it as a fraction, we would say how many heads are there on a quarter or a coin, 1, over how many total outcomes. There could be a head or a tail, so there are 2 outcomes. So we would write that as a half. Oops, kind of big. Okay, so you can write it as a fraction. You can also write it as a decimal. Half is 0.5. And to convert that to a percent, remember we move it over 2 times, add the 0, it would be 50%. Okay, so you can see it as any of those ways. They will specify in the problem how they want you to write it, but you will see it in any of those ways. Fraction, decimal, or percent, and they're all equal. All in between 0 and 1. Oh, I just gave you the next answer. So probability is always between 0 and 1. The closer the probability is to 1, the more likely it is that it will occur. Okay, so we have this nice little scale. 0 is impossible, 50-50 shot, like the heads and tails, and 100% is certain it's always going to happen. Okay, another way we can think of that is with the weather. If there was a 90% chance of thunderstorms, or rain, you would want to bring your umbrella. But if there's only a 30% chance that's closer to 0, then, it's not as likely that it'll happen, or it has a lower probability of happening. Some of the key words that you're going to encounter with probability, the first one is or. Okay, so when you see that word or, that signals you to add the events together. Today we will use or, but we will not use and. However, I want you to know what and indicates. And means you want to multiply the events together. Okay, and we'll talk about and with compound probability and independent and dependent on Monday. So you don't really need to worry about and right now. Alright, so moving on to number 4. How do we know what to write in our fractions? Well, when they ask just for the probability of something, we are going to use this formula. Okay, so we're going to say that this little bar here in number 4 is a fraction, and on the numerator we're going to say the number of favorable events. And you can pause it if you need more time to write, over the number of possible events, or excuse me, possible outcomes. Okay, so we're going to use that setup. Number of favorable events. Favorable just means what's the question asking for. And then number of possible outcomes, how many marbles are in a jar, how many heads and tails, so there's always 2 possible outcomes. If it's a dice, there's always 6 possible outcomes. Okay, so we're going to look at number 5. And I want to reiterate what is in bold. Remember to always reduce or write fractions in simplest form. Very important. All right. Now, it says, in a jar of 40 marbles, there are 12 blue, 14 pink, 8 red, and 6 yellow. All right, we're looking for the probability of certain events. Okay, so we've taken the word probability away and we just replaced it with a P, and we're looking for this event of pulling a red out of the jar. Okay, so let's look back at our little setup. Number of favorable events. Okay, so we would say how many red, because that's what the question is asking for, how many red are in that jar? Okay, well, we look up and we say, oh, there's 8 red. So we'd say 8 over how many possible outcomes, how many possible things are in the jar, how many marbles are in the jar. There are 40 marbles in the jar. Okay, is that reduced? No, it's not. So take 15 seconds, think of what that can be reduced by. All right, and hopefully you have decided that it can be reduced by 4. Okay, so if we divide by 4, on the numerator we get 2, on the denominator we would get 10, and look, it can still be reduced. Okay, so you could have reduced it by 8 or 2. And this time we'll reduce it again by 2, and we get 1/5. Okay, so that's my probability as a fraction of picking a red out. As a decimal, 1/5 is 0.5, and remember we just move it 2 times over to get the percent. So, oops. All right, hopefully you have a eraser, because I was definitely going too fast, and I said that 1/5 was 0.5. See, we all make mistakes. I quickly caught that. It's 0.2, which is 20%. Sorry about that, guys. Careless error. All right. Moving on to the probability of picking a pink. Okay, so how many pink are in the jar? There's 14 pink in the jar. How many total marbles? There's 40 total marbles. All right, so what can we divide by? Think about it for a second. So you can divide by 2. So if I divide the top by the numerator by 2, I get 7. And if I divide the denominator, 40, by 2, I'm going to get 20. So 7/20. 7/20, go ahead and put that in your calculator, see what 7 divided by 20 is. You should get 0.35, and then as a percent, 35%. Got that one right this time. All right, the next one says probability of picking a pink or a blue. So when we see that word or, we know we are going to add. All right, so we're going to add pink and blue. How many pink do we have? 12. How many blue do we have? Oh, I'm sorry. We have 12 blue and we have 14 pink. There we go. Okay, so we add up the 2 and we should get 26 pink or blue over 40. Okay, think to yourself, what can I reduce that by? They're both even, so I can divide by 2, so let's see if we can do that. So if I divide 26 by 2, I'm going to get 13. And if I divide 40 divided by 2, I'm going to get 20. 13 over 20 is 0.65, which is 65%. And that last one, which might cause a little bit of confusion, it says the probability of not picking blue or yellow. So you can look at this 2 ways. You could start with 40 marbles and subtract blue and subtract yellow, or you could look at what's left. Well, we're not going to look at blue and we're not going to look at yellow, so we're going to look at pink and red. So pink is 14 and red is 8. Okay, so those are the marbles that are not blue or yellow. So 14 plus 8, we'd get 22 over still 40 total marbles in that bag, in that jar. And if I divide by 2 again, I'm going to get 11 over 20. 11 over 20. That cannot be reduced any further. 11 is what we call a prime number. So you'd say it's 0 point, and you can divide it in your calculator, 55, which is 55%. Okay, pause if you need to fill anything else in or if you have any questions. Otherwise, you can keep on going to number 7. Okay, so hopefully by the end of the week you have a pretty good grasp of the difference between theoretical probability and experimental probability. So if you think back to number 5, we were talking about the probability of picking one marble picking one marble out and seeing what's the probability of it being red or pink or blue. That we didn't actually conduct an experiment. Okay, so we would consider that theoretical probability. All that means is in theory, right? It's a hypothesis. It's what should happen in a perfect world, but it doesn't always happen. We haven't conducted an experiment, but it's in theory. So you see that root word theory in theoretical. So theoretical probability is the probability of what should happen. And again, what is expected? Anytime you see that word expected, what is the expected outcome? You want to think theoretical. Very, very important. Okay, so is number of favorable outcomes over the number of possible outcomes. So same thing here as regular probability. When it doesn't specify, we can assume it's talking about, in theory, what should happen. All right, so here we go for number 8, back to the dice. What is the theoretical probability of flipping a heads on one coin toss? So you want to ask yourself, how many heads are there, right? Because when we talk about how many heads, that's the favorable outcome. That's what they're asking for. They're asking for heads in the problem. So there's one head on a coin. And how many possible outcomes are there? Well, there's a head and there's a tail. So there's 2 possible outcomes, and half is 50%. Okay, now we see that word expected. What would the expected result be if you flip a coin 100 times? Okay, so we want to think about 100. And if it's 50-50, what's expected, how many times would I flip the coin, or how many times would it land on a head, and how many times would it land on a tail? Well, it's going to land 50 times on heads and 50 times on tails. Now, that's actually not accurate. Well, it could be accurate, but it probably won't be. You would probably get something around mid-40s and maybe mid-60s or so, but if we were being asked what would be the expected result, we would say 50-50, okay? Number 9, if you randomly choose one of the letters shown in the word explore, what is the theoretical probability of choosing a consonant? So their question is asking for choosing a consonant, so that's my favorable outcomes. So we would say number of consonants over number of possible outcomes. So how many total letters there are in that word. Okay, so we'll have a little English lesson real quick. How many consonants are in this word? So remember, vowels are A, E, I, O, or U. So then we're left with all the other letters being consonants. So X, P, L, and R are consonants. So how many consonants do we have? We have 4 over the total number of letters, which is 7. So the probability of picking a consonant out of the bag or from this word is 4 out of 7. And that cannot be reduced.